Hello and welcome to my YouTube channel GeoHub. Don't forget to subscribe. And today we will start a new course, and that is related to the sedimentology. Now, there are two types of sedimentology. One is clastic sedimentology, and another one is carbonate sedimentology. Later on, we will cover the carbonate sedimentology, but this course is uh, comprise all those lectures, those series of lecture which is uh, describe and explain all those topic which is come under the category of plastic sediment. Ever wonders how rock tell stories? Question. Yes, they tells a lot of stories because you can study the rocks, their depositional environment, and then you can correlate those depositional environment to understand the history of the earth. Join us to decode the mysteries of clastic sediments, which is an interesting course. And table of contents is covered, or the topics to be covered in this series of lectures under the clastic sedimentology is grain texture, fundamental description of granular material. What are grain? How we can describe its textures and what the fundamental granular material are, their types. And then the grain textures have grain size, grain shape, and then porosity and permeability, which is very much important, and then the grain orientation. The second topic is classification of heterogeneous clastic rocks, for example, arenite, rhyolite, and lutite. Then the third one is unidirectional fluid flow and sediment transport. Because I'm telling you at the start of this lectures, when the sediments is weathered, it is then transported. All the way when they are transported, they carried by different agents and then they're deposited. So you heard about presence is the key to the past. So the past environmental condition or the condition through which the sediments is going through all those processes, physical and chemical, will be coated or will be stored into these sediments. So our agenda to understand the sediments, the processes, and then we get all those information and then understand the history of the region and the history of the earth. Characteristics of unidirectional flow: simple fluid flow, fluid gravity flow, sediment transport, modes of transportation or transport, initiation of transport, and then the fourth very important is the bed forms. Certification you under unidirectional flow, bed forms, how it is formed, what it tells us, and terminologies related to the bed form, like ripple marks, the sequence of the bed forms stability fields, how and which time it will be stable and which time it will be not stable, and it tells all this process. Cross stratification, bed form by bed forms, and then terminology of those bed forms. Origin of cross stratification, from where it is in cross laminations, tell us a lot of story, and the depositional environment as well. Cross stratification and bed forms. The flow bed forms and stratification you under oscillatory and combined flows. Then we will discuss this topic, and subtopics are characteristic of gravity waves when the sediments is flowing in the water on wind. They affected by gravities. Bed forms and stratification you under symmetrically oscillating currents or symmetrical waveforms. bed forms and stratification. You want to combine flows, and then we have to discuss the enigma of a homology cross stratification. So now start from the clastic sedimentology and we define it and the study of sediments and sedimentary rock that are made of a particle that are the solid products of weathering at or near the earth surface. About the weathering process, we have to cover all those weathering types, but literally weathering means the broken down physical and chemical broken down of any rock material. When they are broken down, they are converted into sediments. Then these sediments, these particles that are solid particles, solid products, they are the byproducts of this weathering. They are generated near the earth's surface. Now what can happen and what are the products is gravel, sand, mud, and mud contain the silt and clay as well. We will cover all those scales as well. Few scientists are published those scales from the beginning up to now. But literally, these are the products, or these are the weathering products up near the surface. They are produced by those weathering processes from the source area. Conglomerate, sandstone, and siltstone and shale are the other products that are generated from these gravel type. When the gravel is broken down particle, when they are transported, they are deposited. When they are deposited, so the spherical particle are clunched together or combined together in the presence of cements, or sometimes there is no cements at all. We will cover that in lutite rocks as well and the conglomerate types. But when gravels combine, they generate or produce a conglomerate rocks, then produce sandstone, and mud, silt, clay, siltstone, and shale will be the last end product. Purpose of the course, which is very much important to understand what we want to deliver, what is the unique thing, and this type of course is to introduce terminology and fundamental concept of the descriptions and interpretation of clastic sediments and sedimentary rocks. This was the purpose of the course. You have to understand the basic terminology and then the fundamental concept. What are the basic concepts? They are description and interpretation of clastic sediment. We will try to enable you to study those rocks in the field, and then the lab work, what the analysis you can do on the basis of those description you carried out from the field, and what are those vectors, what are those things, what to understand there in the field. Literally, when you come across a lots of clastic sedimentary strata, you have to get the description out of this bed form, and then that description need interpretation. Why you say that this bed form is a sandy bed form or a muddy bed form or a conglomeratic bed, and they are and their sequences as well. So what we try to do is to understand the terminology, first the theory, then the basic concept, and then how we can describe anything in the field. Then when you have to describe these things, then description need interpretation of the clastic sediments and sedimentary rock to understand the larger picture, the larger picture. For example, you understanding the depositional environment, what are the major processes happening in the depositional environment. Then when they are happening, they produce certain byproduct in the form of clastic sediments. When those clastic sediments is transported, what are the effect of those transporting agent to those sediments? And then literally we will understand what are those byproduct or the end product in the form of conglomerate sandstone and sandstone. We targeted these lithologies and understanding this and describe it in detail in the field, and then we have to interpret with those basic concepts to understand the history of that region, the history of those earth. Why study clastic sediments, which is an important question. Sedimentary rock make up only 7.9% of the Earth's crust. Relative abundance of the rock and the Earth crust. For example, you have a bunch of those rocks, and the Earth crust is igneous rock. More of that are granitic and igneous rock. They are solidified product of the magma or lava oozes from the subsurface in the Earth. Then we have the pre-existing rock, and they are altered by heat and pressure metamorphic rock, which is 27.4%. These are the MCQs, which is very much important. You need to remember the 64.7, 27.4%, and then we have what we targeted is a sedimentary. 7.9% of those sedimentary rocks is present in the earth crust, which is a third. Okay, relative abundance of rock at the earth's surface. Now, then we have to see igneous and metamorphic rock is 34%. They are relative abundance of the rock and the earth's surface. They are the earth crust, and this is the earth's surface. Shale is 35%, limestone is 16.5%, and sandstone is 14.5%. You can see here a bunch of those rocks. They are soft rock, which is relatively abundant in the earth surface, where we live in the earth surface. So now, this is the importance that is encourage us to understand what are those rocks, what is shale, what is limestone, what is sandstone, how it is produced, what are those things, what are those products that are tell us about the story of the earth. So 66% of the surface of the earth is covered by sediments or sedimentary rocks, which is encouraging point, which is encouraging us to study these sedimentary rock. Human interact with the earth largely at or near its surface. We human interact too much to the earth largely its surface. What are those interactions? We will cover it later on. They grow food on it. We can grow food on it, which is this clay, which is salt, which is sandy stuff, and they can different types of the sands, and then we have to grow our food on those surface. So that is what important. That is what the importance of those sedimentary rock to be understand thoroughly. Building structure on it. Well, lots of sedimentary strata. For example, limestone or sandstone, or these material are widely used in the construction buildings or structures. Any building or any structures that is produced or that is built on the surface will have to be on the bed or from the bed, or that bed must be a soft rock, probably limestone, sandstone. Take resources from it, which is quite important for us. Quite important for us. We have dig into the earth's surface, and we can extract the oil and gas on the surface from those strata. So these are the encouraging factors what we need to be understand, and it's important to deliver or understand the fundamentals of those sedimentary strata. At the same time, they highly garbage. There is advantages when we interact with the anthropogenic activities is going on a lot of today. A high garbages and other waste material in it. So what can it do when we hide garbages in other products material in it? Modify its physical and chemical properties so that it is no longer usable by them. So due to microplastic, due to other chemicals, due to many of those industrial products is carried to these strata, which is obviously a porous media, soft stone, and then there will be a diverse effect on its chemical and physical properties. But whatever there is advantages as well as there is disadvantages as well, because we human interact with that surface and we utilize different things. It is important to understand the various properties of the sedimentary cover and have a systematic method for describing these properties. So it is important to understand what we need to do. We need to educate our community. We need to educate the social circle to understand the properties, and then you can interact to minimize those dangerous impact to the environment, and inversely these properties is then hurting us as well, one way or another way. Sedimentary rocks record the history of the changing environment on the earth. What I'm saying, the basic point is sedimentary rocks record the history. What history they have? They have the history of changing environmental condition. What are those processes? They undergo all those processes. Consider it from weathering to transportation and then the deposition. Later on, when there is activity of tectonic activity, upthrust those strata are deposited layer horizontal strata. Then this horizontal strata is also recycled with the tectonics. So 2 or 3 cycle of deposition or anything what the earth process on those sediments will be recorded or well recorded in that sediment. So it is important point to understand the sediments, the processes, and then we collect those information and produce or generate a historical background of those processes, and then relate it to the earth history. Based on the recognition of the signature of changing environment over time as preserved in the rock record. Rock record can preserve all those signatures, all those processes, which is from which the sediments is gone through. Environmental interpretation of the rock, which is important. Depositional environment, we will understand the depositional environment from those sediments or sedimentary rock, and plus age of the rock. If you have environmental interpretation of the rock, if you understand the environment of deposition of those rocks plus the age of the rock, then you have the earth history. Then what? Then you have the earth history. Large scale cross breeding, you can see here large scale cross breeding is here, which is 240 million year old rock in the central USA. Another picture, wind blown sand dunes. The central USA was a desert at that time. Environmental interpretation, what does it mean? The present is the key to the past. Now we have to go through the bottom line to understand what we need to be and why it is so important for the clastic sedimentology to be understood. By examining the characteristics of various environments on the earth, today we can interpret the environment in which ancient sediments were deposited. Look like this. You can see here, those are the sedimentary strata. And these are the moraines, or these are the sediments which is carried all through this way by these agents of water along this gully. So the man is standing here is a scale, and you can see here the sedimentary strata is deposited one above the other, and age of the rock. Based on relative age relative to associated rate, we understand the age of the rock. What are those processes which is happening past and then second and then third, and then we correlate all those ages with each other. Absolute age, we have to radiometric dating, we understand that as well. Earth history, the history of changing environment on the earth history is important. So, the description and classification of rock sediments and processes and their products and the sedimentary record that aid interpretation ancient in sedimentary environment. Uh, this is what important is is the bottom line of all those discussion. Processes and their product. What the processes is happening, what the byproduct of those processes, and the sedimentary record which will be recorded at the sedimentary record and aid interpretation and shed sedimentary environment. From the process, from the product, what we have the product. We don't have the processes. If we study those product, we will understand the processes, and then we understand the processes, we will develop a sedimentary record from out of those products. And then to different proxies. Different proxies mean you have to go to the field, you have to collect the data, then you have to go to the lab, then you have to produce or analyze those data. The different processes, model composition, somewhere we have to understand the grains, we can to see the grains, count the grains, and then we have to produce, generate 10 sections and the lab, and then we have to uh, understand the geochemistry of those sediment. From all those proxies, we will understand what the processes is happening, and then understand the sedimentary record, and then interpret those ancient environment. What are the environment of that deposition? And that environment of deposition, and then correlate to the millions years old age earth crust or the evolution of those earth. So thank you for watching. Don't forget to subscribe my channel, like, share, and subscribe to my channel G Hub. Thank you so much. If you have any question, we have to a lot of lectures we will coming interacting each other. And if you have any question, please ask it in the comment section. I will try my best to answer it. Thank you.